you would have also had to have been given a K at some temperature in order to get K as a function of temperature like that. 19. I doubt it matters, but yeah, 19. Okay, any questions thus far? We just set up the parameters from what we were given, right? Okay, so how do we solve the problem? I want to make the ignition extinction curve. So what is that curve of? What derivative? No, you're thinking of the other curve. I'm not trying to make the S curve one. I'm trying to make this one.
Plot V or G versus T, and then R versus T.
You didn't need to set DG for the
Well, let's first just start with what are we after? What is this plot? What are these? What is the ordinate in the abscissa?
G is
The temperature at steady state, and what is the x-axis? The inlet temperature, right? This is what it's asking for. If you're asked for an ignition extinction curve, that's what it's asking for, okay? Not the one that shows G or R as a function of T. That's how you get this curve.
You did TC before against TC.
No, I didn't.
I took a picture of it.
Are you sure you're taking a picture? I mean, I might. If I did, then it was a mistake. You don't have to show me the picture. I'm pretty sure it was T0, but. Okay, so anyways, you're thinking of the stability curve, buddy. I think, but I'm not 100% sure.
What's it from? S.
Yeah, that's a stability curve. That's a different curve.
Oh, darn.
It's all right. You'll get one. You've probably got like a dozen on me, but not today. So yeah, we want the steady state temperature versus the inlet temperature. Okay, and we were given, again, kappa is equal to 5, Tc is equal to 300. Okay. So how do we make this, how do we get the data points for this guy? Now what plot do we want to make?
T versus T.
Yeah, we want to look at the curve versus temperature for G of T and R of T. This part gets text heavy, so I'm going to move it over here. This is where the ability to do it on a board kind of disappears. You're obviously going to want to use some sort of plotting software in order to make this sort of most effective. You want to inspect. So notice I gave you an inlet temperature. Obviously, to make the extinction coefficient or the extinction ignition curve, you're going to be changing that inlet temperature, right? Yeah.
Instead of plotting, you just take the derivative and set the higher temperature for ignition and the lower one for extinction.
Say that again.
Could you just take the derivatives of G and R so that equal each other, find it that way, or would that not work? Instead of plotting, could you just find your...
How do you know if there's, how do you know that you're at, all right, so first of all, let's take it step by step. Do I know that these lines are going to intersect at 3 points before I make a plot of them? Do you guys know right now that the points are going to intersect or not? No. or you're gonna know they're gonna intersect once, but you don't know how many times. Okay? So at t0 is equal to 300, I could be here, I could be here, or I could be here, or I could be at one of the tangent points, here or here. So there's either going to be 1 to 3 intersections. I don't know how many. Now for each of those intersections, G is equal to R. That much we know, that's why they're called intersections. Are the slopes equal? Yeah, only for 2 of them, right? For the high and low tangential point. That's the only time that the slopes are equal. So at this temperature, you do get 3 intersections for this problem. At that temperature. I'm going to put up the curves here in just a second. What does that mean?
Slopes are never equivalent.
Why are they never equivalent?
So you can go under that.
In that region, there's
Instability.
So which curve is that, G or R? Alright. So this is when T naught is equal to 300. So what is the ignition, which point is the tangential point for ignition? Yeah, somewhere in here, there'll be a point where you get a curve like that, right? We don't know what TO is at that point, but we can see on the plot that there would be such a curve. What does it mean when he's got here in the notes that there is no extinction temperature for this kappa value? Yeah. If I'm here, what happens if that happens and this is 0 Kelvin? Right. So that can happen. That just means that there is no extinction. Okay, so now in order to find this point, what do we do? What do we do to solve that? What 2 equations? We have G is equal to R and dg dt at t star is equal to dr dt at t star. For this problem, you get TO star So when the feed is greater than this point, then what happens? What do we call that event? Ignition.
Do you go over the extension so you know it does not exist when alpha k is equal to 5?
Is because you have to get so cold that you can't run at that low of an inlet temperature in order to hit this point. There is a limit on how cold you can feed things. So mathematically, there's still a tangential point, and if you draw this tangential point, you'll get another intersection. But that mathematical intersection is meaningless physically. Yeah.
So the ones for orange yellow have the same slope, right? No matter what.
Yes.
TO.
I mean, yes, its slope depends only on that's the equation for its slope.
So what I was saying earlier about like solving it non-practically, if you know that like your GFT is always going to be some oil, then it's always going to have two intersections with lines of that slope.
Oh yeah. So if you were just looking